All right, so in this video, I would like to look at some graphs of logarithmic functions. So you can kind of get an idea of what exactly a logarithm is in relation to an exponential function. So let me share my screen. And we're taking a look at Desmos. So let's start with an exponential function, y equals 2 to the power of x. All right, this is an exponential function. Every exponential function is going to pass through the point 0, 1. And then I should say every basic exponential function. There are transformations and translations of exponential functions, but we're just talking about the basic exponential function having base 2 and exponent x. Whatever your base is doesn't matter. Your every exponential function, no matter what the base is, if you raise it to the power of 0, the base, you're going to get 1. So 0, 1 is a point on the graph. And you can see if I put in a different exponential function, y equals, let's say 3 to the power of x. You can see the shape is a little different, but it still passes through the point 0, 1. So let's take a focus on y equals 2 to the x. Now, if I interchange x and y, watch what happens, okay? Now, instead of y equals 2 to the power of x, I'm going to put in x equals 2 to the power of y, okay? And look at what happens. I get the mirror image of y equals 2 to the x across the line y equals x. This line here, y equals x, x and y are identical on that line. And so it makes sense if you switch x and y, you're going to get a mirror image. So like if this point right here is 2, 4, let's see if I can line it up right, 2, 4. I'm trying to, okay, let me just plot it. That's probably the easier way of doing it. Okay, you can see that if I plot 2, 4 and then plot 4, 2, I get this point is reflected over here. So this is 2, 4, this is 4, 2. And that's true for all these points. If you interchange x and y, you're going to get a function reflected across this green line, which is y equals x. Okay, so the red is the exponential function, and the purple is the logarithmic function. This equation here is the logarithmic equation for the exponential. So these are kind of pairs here. They go together. Now, if you change the base, so if this gets changed to 3, then the corresponding logarithmic function is going to also have a base of 3. Well, I kind of messed it up here. Hold on. So 3 to the power of y. So the pairs are formed based on the base, okay? So here we have the exponential function y equals 3 to the x. Here's the logarithmic function. Now, the formula for that is x equals 3 to the y, but to write it in function form, we're going to write it as y equals, because remember, y equals f of x, y equals log, and then I'm not sure how to do a subscript. Let's see, I should know that, but I don't. I never actually, it's been a while since I've graphed a logarithmic function in Desmos, and I'm not seeing, let's see, functions, here we go. No, let's see. There it is, log base A, okay. So, sorry, it's been a while since I've done this, so functions. You scroll down here, you can get log base A, there we go, and the base that we're looking at is 3, and then we're putting in x. Okay, so you can see that the purple and the blue are the same function. This is in symbolically how we write it, and this is in function notation. So basically, we're saying that y is the exponent if the base is 3 for a given value of x. That's how we evaluate a logarithmic function. We're looking for an exponent. So if I plug in 9, let's say right here, if I take x equal 9, what's the exponent on 3 that gives me 9? Well, the output is 2. Because 3 squared is 9. So that's how logarithmic functions work. And this is the graph of a logarithmic function. So let's focus on graphing because that's what this video is all about. So I'm going to go ahead and get rid of all this other stuff. Here is the basic graph of y equals log base 3 of x. Notice that there's an asymptote at the y-axis. So the y-axis is an asymptote. And that means the domain for this function is all real numbers greater than 0. If I take a 0 and try to plug it in, I'm going to get an error message. Or if I try to value a log of a negative, I'll get an error message. So the domain is all real numbers greater than 0. Now, if I want to, let's say, graph the reflection of this across the y-axis, I would just put a negative. Notice the negative is inside the function. And when you have a negative multiplied inside, you're going to reflect across the y-axis versus if you have y equals, let's they really make you hunt for it here, log base 3 of x, and if I put the minus in front, it's going to reflect across the x-axis. So here you can see the negatives on the inside, it reflects across the y-axis. Here the negatives on the outside of the function, it reflects across the x-axis. And then you can do things like shift it around. So if I shift to the right by 2 units, you can see that the asymptote, which was the y-axis, gets shifted to the right, and now the line x equals 2. And so here the domain of this function is going to be, just a second, the domain of this function is going to be all x greater than 2. All right, let's graph log base 2 of x minus 3. So I'm going to look for my log function here. Log base 2. Here's log base 2 of x. Okay, that's the basic log function. Now if I want to subtract 3 inside the function, it's going to move to the right 3 units. And you can see how everything got shifted to the right by 3 units. So that's how we graph log functions. You can use your graphing calculator to do this, or you can just use what you know about transformations and translations to shift things around or stretch, whatever you, or reflect, whatever you want to do. Whatever you feel most comfortable with is fine.